Welcome to another CO2 Monday in the Refrigeration Mentor podcast. Thank you once again for taking the time to come and hang out with us each week to talk a little bit about CO2. And also, thank you for sharing this information. This is how more people are learning about CO2 and just really diving in to get the fundamentals as well as some of the advanced topics from some of the experts that we bring from around the world. This week, got a good friend of mine from Copeland, Brent Cheshire, and Brent is going to talk about his E3 and CC200 platform. Please ask some questions for those that are listening to on the podcast. You can check out the YouTube video, probably the first link in the show notes. Brent, welcome to CO2 Monday. How you doing?
I'm doing good, Trevor. Always good to see you and talk with you.
Yeah, no, we've been playing this for quite a while, and finally we got able to get hooked up because as we both talk about, CO2 is growing at a rapid pace here in North America, around the world as well. And controls is one of the things that a lot of people don't know much about, could be a little bit afraid about, and really would like to just learn a little bit. What have you been seeing after we get into your introduction and find out your role? What have you been seeing on that control side for the technician? So why don't you introduce yourself?
Yeah, okay. So you familiar names on there, so it's good to see. So a lot of new names here too. So a little bit about myself, Brent Cheshire. I'm with Copeland, formerly Emerson, as most people know. We've transitioned over now to a standalone company as Copeland with a very strong branding behind us from the compressor side. And a bit about me, I've been with the Copeland organization for 13 years. Started off in Australia with those guys, doing CO2 and case controllers. Previous to that, I was in refrigeration technician, much like most of the folks here on the phone, I guess. So 10 years supermarket mostly, convenience store and quick service restaurants too. So a little bit of hands-on experience before I made that transition to try to get away from that on call and weekend work, right? Just like everybody wants to make your millions and get out. I never made the millions, but I needed to get out. So moved over to Copeland, and I've lived here in the US now for almost 10 years, a couple of different regions up in the Northeast, kicking off CO2 about 6 or 7 years ago with some of the Northeast retailers, case controllers. And then I've slowly made my way down south to Georgia to warm up and thaw out, based here in the Canastore office from where our controls company is based out of. So been down here a couple of years now, and yeah, we're definitely making some inroads in CO2 throughout the industry, and a lot more coming, which I'm excited about. CO2 has been my passion now for almost 20 years. So yeah, thanks for the introduction.
Yeah, no. And like you have so many installs under your belt. Like he's a veteran for CO2 controls. I think 300 plus applications you got out there.
Yeah, I kind of stopped counting out after 300, so, and I slowed down a little bit, trying to get the education, just like yourself, out to the younger guys. I'm still fairly young myself, but we need to spread that wealth to these young kids coming through.
I love that. So we were down in Washington together and we were talking about that was one of the things that was a hot topic was controls and CO2 systems and how we need to help the contractors out there to help their team because a lot of the time, and we talked about it there, like contractors have one, maybe two guys that can do the commissioning and the install. But when you have six stores on the go, it's really difficult to bounce those guys around to do all these startups. What have you been seeing out there in the field?
Yeah, much to that, Trevor. It's look back probably 5 or 6 years ago. The end users were dabbling in CO2, trying to get a feel for it. It was about one or two per end user. We had time to work with contractors, and it would kind of be the same guy over and over, trying to get him up and running, and then they would only do a handful a year. So it kind of kept that one or two guy busy. Now with regulation changes and the push for natural refrigerants and trying to get that lower GWP, these end users are now rushing at us, right? So what we have seen over here at Copeland is definitely an inrush of, hey, come and help us and get us trained. And then also hey, we need you guys to come out and help us because we're just not going to be able to go through every single job on our own, right, at the pace the end users are moving. So it's a good problem to have, but obviously folks like yourself and here over at Copeland and others in the industry are really trying to train everybody as quickly as we can.
Yeah, and I think that's super key too, because controls, they're not difficult if you spend the time learning them. That's the thing. It's like refrigeration. Refrigeration is not difficult if you spend the time learning. So it might take a few years. It doesn't happen overnight. But if you have a background where you navigate it, maybe you put some board points in, which we'll talk about some set, and it makes it easier. But I think a lot of the time, some people just need a kick in the butt and say, here it is. This is what you got to start learning to get them off the ground. And also, we need contractors to give these technicians some time to do the training, because a lot of times they're just putting fires out everywhere, and there's just no dedicated time for training, which hopefully that we can change that. Today we want to dive into the E3. Let's just give us an idea of where the E3 is at versus the E2, and then I think you have some sites that we'll dive into and give the audience an idea of what it looks like now.
Yeah, so for those that are familiar with the E2, so our legacy controller, which has been around 20 plus years now in most of our grocery stores around the world, really robust, really strong. Like you said, very, very easy to navigate once you learn and take the plunge. So we've evolved through technology and advancements in software and UI and things like that is born the E3. I think the marketing guys tried really hard to get a new name for us, but we settled on E3. Make sure we keep that family going. With the E3, it's kind of boiled down to almost very similar layout as far as the way our applications are from the E2. So if you've been servicing a store or some plant equipment for the last 5 or 10 years and you know how to navigate through the applications and F2, next tab, things like that, the UI guys really took an importance on trying to keep it as close to that feel as possible, but with an updated color screen, graphics, logging, and things all into one to bring it up into our future state of growing our development. Now it's got a touch screen as well, so gone are the days of the onboard keyboard, which was always covered in oily fingerprints anyway, and much will be the touch screen. But yes, we have tested it a few times with different oils and things like that from the fingertips, and it's standing up to those paces so far, and it's really, to kind of bring it back to it's really a true drop-in replacement for the E2. It is backward compatible with our legacy IO boards, so our multiplex boards, any connected devices like case controllers and things like that. You don't have to go and replace the rest of your equipment. You would just change out that front end from an E2 to an E3 and move on. Life's great from there.
Yeah, and that's awesome. That's what makes it convenient when you want to do an upgrade, because going forward, you're going to start to see, I think down the road, it's like any product, parts are not going to be, you're going to have more efficient, more effective parts. So the legacy parts won't be available, and you're going to want to upgrade to the latest technology. Like if you want to probably Bluetooth log in, remote dial in, a lot easier, better to see it on a phone or on a computer. Because the ultrasight, I don't know, looking on old ultrasight on the phone was not the greatest, but
yeah, if you could get it to work.
But going forward, I see this. I was down in California with Mike Hill, and he was showing me some. He was just going through it very quick, showing me some of these advanced features of just like quick information, or the question mark. You used to have to use the question mark all the time on the E2, but nobody ever noticed the question mark was there, but no one ever pushed the question mark, because I didn't for years until someone said press that button there, and it pops up what the information is. But on the E3, it just, you got the whole manual in there. I'm sure at some point you'll even have videos where you press it and it'll show a walkthrough video on it. This is what advancement's all about.
Yeah, absolutely. And like you say, I mean, it's always, I love the question mark comment, because it always was that everybody was too scared to push it because they didn't know what it did. But now it's laid out right in front of you on the screen, and you can bring up the manual just as you said. And in future state too, we can also load in other PDF documents and things like that. I don't want to talk out of school for our engineering team, but they're looking at ways on how it's now connected to the cloud a lot easier too. So what can we bring in from the cloud to make everybody's life easier? Is that the store print? Is that IO legends and things like that? So we can start loading those kinds of things in to make it easier for everybody that's out there at 2 o'clock in the morning.
Yeah. And that's one thing that Mike showed me, was like, watch this, Trevor. He went, bam, there's the wiring diagram. So it laid out the wiring diagram that I was looking at on that microthermal board. And I'm like, this is awesome. You don't have to go and scramble around. It's nice to have the paper copy. I like the paper copy, looking at it. I can trace it out, but just having that there, so there's no excuse saying, "Oh, someone took the the wiring diagram and you don't have it," right? So I like that feature. So why don't we jump in and maybe kind of give the audience what a CO2 application would look like? Just share the screen. So this is actual a CO2 site right now.
Yeah, so this is a live site we did for a customer here up in Minnesota. If for those that might be familiar, it's got a quick trip. We mentioned Washington D.C. just earlier, so we were up there participating with the Quick Trip guys on their CO2 evolution. So you can imagine this is a gas station slash convenience store, right? So starting to cross over from the supermarket CO2 world into small format convenience store, gas station type size stores. So it's really out of their wheelhouse to move from HFC refrigeration racks to CO2. And again, not in a very big region of the country. It's not too far from Minneapolis, but it's far enough that they don't have a very big contractor pool that's trained up in CO2 just yet. So what we did to help them cross the bridge and their contractors and on-site or internal facility guys was to build out this, what we call a floor plan or a map of their system. And what that does is give them an easy point to go in and look for the system, what the compressor statuses are, and your gas cooler, your high pressure valve, your bypass valve, temperatures in the circuits of the cases, walk-ins and things like that in one clear view, rather than having to go around like we would have in the E2. Was to go from one application to a different application, screen after screen, pushing buttons, right?
Yeah, and that's what's so awesome about it. Now I got all of it in one shot.
Yes, certainly. We've done a few of these now with a few different customers, and like I said, it's been one thing that makes their life a little easier, at least from the. I wouldn't like to say it's painful for these guys to start crossing the bridge, but they feel a little bit uneasy or nervous about it, right? It's not entirely new. Refrigeration is refrigeration at the end of the day. The basics still apply. It's just things are different, right?
Yeah. Well, there's a lot more controls. There's a lot more components, electronic components compared to the standard synthetic refrigerant system or refrigeration system. So it's important to get up to speed. And this is what I hear too, is that depending on what part of the world you're in, even what part of the country you're in, the skill level is different. So someone in that city may have been working on some E2s would have a better shot at learning this quicker to someone who has not worked on controls before.
Yeah, it's a good point because there's still parts of the US or North America and even parts of Australia were the same when I lived there. You get out to the rural towns and things like that. I mean, they haven't had a need for electronic controls. There's still sites you go to that have pressure controls and thermostats, right? It's just the way of life or the way of that part of the world. It's hard to get components out there or quickly and things like that. So they've kind of relied on, I wouldn't say they've been reluctant, but it's going to take them a little bit more time to adopt. I think regulations is going to accelerate the rural areas as well. And again, back to us talking, we probably owe the rural areas more than anybody to really get people educated out there faster.
And I agree with that. So I love this. So I love you log in and then you'll see the layout of the store. So you got compressors, you got your gas cooler condenser, high pressure valve. So it gives you kind of an outline of what's going on with a lot of pressures and temperatures. If I was a technician and I came into a store and so I knew how to log in at least, but after that, what would be the first few things that should look at if I'm going to service the store?
For me, the first thing is all refrigeration guys know best, right? Is we don't always, we're not only looking with our eyes, we're also listening out for things. I mean, first thing I look at is the compressors running. If I woke up in a quiet rack, I mean, we know we're in trouble, right? For the most part. So, we come in and look at the rack, or what the rack is operating for, and the E3. So I probably went a little quicker. I get really in the autopilot zone sometimes if I navigate quick, but I go to the suction group here of the medium temp compressors within 3 clicks on the E3 from the screen I was in. Really quick to navigate on the E3 to get where I need to be. So this is again, the medium temperature suction group on this site. And the beauty of E3, and again, the E2 was and is a great product, but now the E3 gives us so much more information in one screen. We've added all our data points to the side, and it's fully customizable down that left side. For those who can see the screen, and you hit the spanner at the bottom, I can add or subtract values from my status tile on the left. So if I want to bring in compressor proofs or alarms, or we could bring in the set point change or things like that, you just go in and okay, I want to put in these in my tile because that's what's important to me. And that's customizable down to, as long as the end user allows you to have a personalized login to the controller, you can customize these tiles and these layouts for your login, which in the E2 was impossible to do. When you create a login for Trevor and you say, hey, I want to see half of this information and only half of these logs, we can customize that look, and you can customize that yourself. You don't need us to do that for you, but you say, okay, what's important to me when I'm looking at this rack? I like to come in for a busy screen, as you can see.
Yeah.
More information at my fingertips, the easier it is for me to troubleshoot.
Okay, I do. So that's a good point. For example, I could, or a customer could set you up and just say you have 10 technicians that are servicing at a store. Each technician can have their own login and password. Yeah. Okay, and who sets that up? Would that be the end user setting that up, or would that be the contractor themselves?
I mean, it's typically an end user, especially with the bigger end users that we all work with, right? Is normally in control of user management within their controllers, because obviously they need security. And then two, they want to make sure the assets are protected for anybody the uneducated, if you would, not making changes within their system to put food quality at risk. Normally what we do at Copeland is try to engage or enable the end user to own the user management process. And then sometimes, it might be on the maintenance contractor as well. Like you say, you might have a crew of 10 guys that may service a hole on this site. And you can create a login per service technician. And like you said, then we can customize those looks and how the layout looks for them. And then also it kind of gives some accountability too, is what the end users like about that, is they know who's logging into the controller if it's a personalized login.
I think that is huge. If anyone's listening, whoever's listening and watching this, you need your own login and password, and you should not be sharing your stuff, because I've seen this time and time again. When I was in the field, people don't like to write down the logs. They change stuff and nobody knows who it is. You can go in and read the old log, but who was there at that time? This is to help you, because if you make a mistake and you change something, or it's your own store, then you understand if someone changed something. I highly recommend having your own login and password, because I've worked at companies where 35 people had the same login and password. So you never know what was being changed. And if you didn't know how to get into those back logs to see what has been changed, then it's like you're chasing your tail for a couple hours sometimes, until you call someone and, oh yeah, I changed this. So it's important for accountability. I love that.
Yeah, absolutely. Like I said, and most of these end users now are getting to a point where food quality is obviously such an important part of their business. The quicker they get food from the farm to the fork, right? And they're part of the cold chain process here, is like that. They want to make sure that, they're not responsible for somebody falling ill or getting sick from that, right? So it's very imperative to, I guess we call it CYA, right, in the industry as technicians.
Yeah. Got a question here. Are there any plans to move the floor plan creation off Connect Plus platform to something standalone to allow contractors and end users to create floor plans of their own, or to factory install pre-configured live graphics?
I believe so, and I don't work in the product management part of the business, obviously, but I do work very close. Part of my role is I'm a middleman within Copeland on the technical side, but I liaise with product management and engineering here at the office almost daily. So as somebody that's obviously been playing with E3s and floor plans already that asked that question, so I'll definitely raise that with our product management group and try to see if we have a timeline or what the vision is there for that.
Yeah, because I'm sure like things, I know for sure it will at some point, because 5 years, 10 years down the road, there's going to be a reno, there's going to be something will be added or removed. It'll have to change, and it'll be just too difficult for all contractors to be sending into you guys would be overloaded with that. So I'm sure down the road that will be a thing. So we got this screen here. We got tile points on the side. You can customize that, which is great, and make it personalized for you when you log in, log out. And then on the right hand side, you have the graph. So you got superheat percentage used for medium temp. So what would be some? Oh, there's a lot there. What would be some of the when you're going to help out a contractor? What do you? Because you like a lot of information. What would be some of the graphs that you would pull up right away? Would it be these ones here, or is there specific ones for you that you would be looking at?
Typically, it's the suction pressure, discharge pressure, the high pressure valve, where it's positioned,
Yeah.
a bypass valve as well, and then what is that gas cooler doing? For a long time, we've always, as most good technicians know, that stable suction control is the heart of a calm refrigeration system, right? Now, my personal belief is condensers have always been important in the system. Obviously, they have a job to do. But the gas cooler is very close to being as an equal partner in suction control in my mind on a CO2. If that gas cooler is not running right, our system is a one upset system, and you'll see valves, high pressure valves and bypass valves fighting the gas cooler as we surge for subcooling and things like that. So they're probably my main 4 or 5 points that I'm going to look at first, just to see and try to get a few days. If you can get a week worth of logs, then great, right? It's all dependent on the end user as well, of how many logs they're keeping. The E3 on board, if we're doing about a 3-minute log interval, can take almost a year worth of logs to about 2,000 points now. So a lot more than the E2 on board, right? And then you see them all on this one screen. I don't have to go digging for these logs. If I have them all set up in my view here, they're always there when I bring up the page.
Awesome. So if I want to zoom in, just say I want to do just one specific day on this, how would you do that? Like if I want to just
Yeah, so the touch screen, if obviously I'm on my computer today, but if I'm sitting in front of the controller, the touch screen is just very similar to your phone, where you kind of pinch and expand type thing. So you would come in on the log point. Obviously, I'm using my mouse click today, but if I wanted to bring in around the July 4, just click and hold and drag, and then these logs are going to reset into a day's worth of logs there. And then you can double tap on the screen or just double click to get back to the previous amount of days that were on the screen.
yeah, that's fantastic. That and that people know how to use that. People use their phone all the time, so
But that's it, right?
that is so key. I see on the top there's a bunch of tabs. You got status, general, set points, inputs, outputs. Can you just explain a little bit about all those tabs and what's the value of them, and maybe one or two of the important ones?
Yeah, certainly. So like I was saying earlier, that the E3 is very similar to the E2 in the way that our tabs are laid out within the applications. As we going through, if you were to go and check, or you're setting up this CO2 suction group for the first time, we're just clicking through tabs to tell it how many compressors we have, what our set point is, and things like that. The most important thing to do on an E3 is make sure that you click edit at the top of the screen. You'll find that one out pretty quickly when you can't go and try or change anything if you haven't clicked edit. So kind of another little feature to stop inadvertent changes. So like sometimes in an E2, I've done it before, and I'm sure many others have, if you're tabbing through all the tabs and you bump a number or a setting change, and then you keep tabbing through, you didn't even know you made a change till you came back out of the application. So like I said, a little protection to make sure you click edit if you want to change any of the settings here. As far as setting up while we're in the CO2 suction group here in the E3, is you would come through and tell it what kind of suction temperature application it is. So you have the option here to do medium temperature, rack, low temperature, or intermediate temperature, which intermediate sometimes is also called parallel, right? So the 3 different types of suction groups we see in a CO2 transcritical system. So it makes it very easy to differentiate between those. And there are a few parameters that will cascade in other tabs depending on what you select here. For medium temperature, it does get you, when we move to the set point tab, liquid injection, hot gas injection, and your oil separator control. Whereas you do a low temperature, it doesn't give you those options because most low temperature systems on the booster transcritical side don't require the liquid or hot gas injection, and most don't even have a separate oil separator where they're discharging straight to medium temperature suction headers. We don't need it there. Why do we show it? So that's the idea of having those there or not.
So I got a question. What if, just say, someone did need a hot gas injection for the low temp or something like that? Could that become available? Can you open that up in the background, or would we have to call you guys to open it up? Would the manufacturer have to call you?
For right now, you would just make it another medium temperature application. So it would give you those options. Just called medium temperature, obviously, because that's what it is today. But like I said, we might see them come future, and it's probably something we might go back and just make that a checkbox to say, hey, do you have liquid injection or hot gas injection per group there?
Let's just dive into this, because I see hot gas injection set point is 20 degrees. So at 20 degrees, when you start to get below that, it's like, okay, we need some hot gas injection. What would that be connected to? Like what board point? And like, I know it's a solenoid, assuming it's a solenoid, but like give some people some idea on the concept of what's happening with that.
Yeah, so liquid injection, what the value we use is calculated superheat on the suction line for the medium temperature coming back, our pressure transducer and suction temperature. So as long as we have those two inputs, we can give us a medium temp suction superheat. We give that a set point of 50 degrees of superheat in this instance, and then also a dead band. So when would we like to cut in and cut out in old school terms, right? And then once you've got those values, and then you would obviously have to have the inputs, like I was saying here. So we would have to tell it what our suction pressure is. So this one is located on one of the input boards for medium temp suction pressure, and then we got a suction temperature as well. And then we would have to give it an output assignment as well, which in this case is, well, this rack actually doesn't have liquid injection by the looks of it because there's no output assigned. But we do have hot gas injection, which is the same thing. So we're just trying to heat the suction instead of cool down the suction. We would assign the output, and in this case, it's on an 8-0 point, which goes to a hot gas solenoid. Obviously, all these things are done behind the scenes by a programmer or a startup guy or a commissioning guy. But obviously, very important to how to read these to troubleshoot. What point is my solenoid?
This is what's great about it. These are the little fine things that you need to go in as that startup guy or that commissioning technician and just double check all this stuff. You would have to now go from here and make sure the wiring goes to that exact solenoid, and you got to see on there, is this the hot gas bypass solenoid? I think that's what they put, HGBP, but that hot gas injection solenoid. This is your verification. Yes, the OEM may have set this up and programmed this for you, but sometimes there's mistakes that maybe happen. Maybe they loaded up a program that wasn't fully configured potentially. So as a startup technician, you got to go and double check this. And I love that you showed that. So thank you for that, because these are the things that we don't see on a synthetic rack really.
Yeah, we spoke about high pressure valve and bypass, right? And we use these jump menus up the top as well to jump from one application to another application. So I was going to go down here and go to our high pressure valve controller, which is down the bottom of the list here, and it'll load up. So I just jumped from one application, which was our suction control, straight across to our high pressure valve controller, right? In the E2, you would have had to go backstairs or home and then go menu 5, 401, and then bring it up kind of thing. So like I said before, you can get around the E3 a lot quicker. Again, product management say within 3 clicks, you'll get to where you need to be.
People that are listening, just so the people are on the podcast, the jump menu is just under the Emerson symbol in the top left corner, and it was the snowflake symbol where it dropped the whole application down. So it says refrigeration on it, makes it so much easier. So thank you.
Yeah, if you hover over it, yeah. So the refrigeration snowflake, and like see, you click that, and it's then a scrollable menu, just like on your phone if you're on an internet browser.
Yeah, awesome. Okay, thank you. And so now we are in the high pressure valve. So you guys are connected to the iPro. I know when I was doing training for Copeland, we had the iPro in there, and I'm sure it's way more advanced than the 6 or 7 years ago, or I was using, or 5 years ago. So do you want to just walk through this a little bit? Because I think this is something that technicians who haven't worked on CO2 yet kind of get a little fumbles, like what's this high pressure valve? What's this bypass valve? I think this is the separation. When you can wrap your head around the high pressure valve and the bypass valve, everything becomes so much easier for CO2.
Yeah, absolutely. It's intimidating for a few different reasons for some people, right? The high pressure valve, just this name is saying high pressure. We're working with certainly higher pressures than most are used to. Even at full 10A, we kind of, when that guy came out, we're like, well, that's some pretty high discharge pressure, right? And now in transcritical CO2, we've taken that to a next level, and now some people call it the magic valve or the voodoo valve or the pressure drop valve. There's a lot of names that people have coined here, but I wouldn't say simply, but the valve's intent is to create a pressure drop so that we can get liquid into the liquid vessel or liquid receiver, as some people still call it. And by that, I mean usable liquid too, right? So there's an important control factor of that where we're looking at the drop leg temperature. So the outlet of the gas cooler or condenser, and trying to create subcooling. So what we're looking at there, like I said, was temperature from that drop leg, trying to maintain a set point, which typical across most of the OEMs is around 5 degrees of subcooling. There's a couple of them that are a little lower and a couple of them that go a little higher as well. And sometimes dependent on the mode the system's operating in. But in essence, it's just one set point, trying to create subcooling. It does have a few different functions, especially on the high pressure side, high pressure valve side of the control, where if the pressure gets too low in the gas cooler, it becomes a holdback valve. And I mean, a lot of people from our low ambient parts of the country very familiar with holdback valves. It is trying to hold back pressure into the gas cooler to then generate that liquid. We're running, again, like I said, in a subcooling mode when we're under normal operation. And then there's another mode where if the vessel pressure, so in the pressure in our liquid receiver, is getting too high, we will try to close that down again and try to stack refrigerant into the gas cooler, because our liquid vessels now got too much pressure that we can't use liquid off it. We're creating too much vapor. It's probably complicated that for a few more people. In my mind, again, I've been doing this now over 10 years, so it's a little simple for me, but I try to put in a bit more of a simple use case from HFC type systems. The theory behind it is we've always done this subcooling, holdbacks, stacking kind of thing. It's in a traditional refrigeration system, right? So the principles are still there. I just noticed this one not long went transcritical too while we've been talking here up in Minnesota. So what it did there was it transitioned from a subcooling set point to a pressure set point. So now we're starting to lose our temperature and pressure relationship because we're above the critical point of CO2. So now it's just trying to maintain a static pressure set point converted from the temperature sensor. Just take out as much heat as we can now from the gas cooler through the valve, still create a pressure drop and get usable liquid.
And I noticed just on the graph there from the 27th to the 3rd, you could see it was running a lot higher, opened a little bit more. And then all of a sudden, it's like someone came and maybe adjusted some parameters, and now it's a bit more streamlined, unless the temperatures were just skyrocketed those days.
Yeah, they were higher ambient days. So you can see down in the set point line down here where the blue and pink is, there were peaks of transcritical operation through the warm week last week before July 4 weekend, and then cooler ambience through the weekend up in Minnesota. It was able to keep us back in subcritical for a few days. I think we're peaking pretty high in the 90s again, mostly around the country this week. A lot of systems getting some transcritical action this week.
Yeah. A couple of things that Brent said. That valve, it's just it's a control valve, but it has multiple functions. That's the big difference. That's what we need to think of now. That the difference is it has more than just one function. It's not only holding back, but it's looking at pressures and temperatures on different sides of the valve, on the gas cooler side, as well as on the inlet and the outlet. So it's taking that controller, and the controller's just telling the valve, we should close off, we should open up. And when you wrap your head around that, you did a good job explaining it. It's going to make CO2 is going to be very easy for you. I think that's it. It does take some time though. Read different manuals and understand it.
Yeah, for sure. I mean, and getting a few hours under your belt on a CO2 system obviously goes a long way. But as far as breaking down the system into sections, Just so I remember when I went through my refrigeration trade 20 years ago now, of drawing out basic refrigeration diagrams of compressors and condensers and metering devices, evaporator back to compressor. As long as you still can break this system down to a basic refrigeration system, for it, that's what it is. Call a spade here, with just a couple of little higher pressure numbers and different effects of ambient and things like that. It's not too far from a traditional system.
Yeah, anything downstream of that high pressure valve is your flash tank, your liquid receiver, whatever. It's all regular refrigeration, just higher pressures.
Yeah, just direct expansion from there. Exactly.
That is it. So it's not that difficult. It's a little complicated. Another thing that I want to point out on the screen, anyone listen, is the valve percentages. If you haven't worked with electronic valves before, you got to just start learning and watching a system when it's running normally, what that valve percentage is. And that's going to be key, because if we were looking at this screen and the valve output one, which I'm assuming is a high pressure valve one, if that was 100% open, that would be concerning for you. Or if it was 100% closed, it would be concerning for you as well, because the system would probably be off.
Yeah, exactly. And then that's for the E3, that's sort of really the onboard graphics now in the screen. As soon as you pull it up, I mean, we can see the trend here from over a week's worth of data. You can see where it's averaging through its operation, right? And like to your point, Trevor, if it's fully open or fully closed and you can't explain why, you've got your trends to go back on. Okay, how does this system normally operate before this thing went silly or something happened in the system? I'm trying to troubleshoot it, right? It's like, okay, I know that my average valve percentage opening is around 40%. I woke up on it now and it's running around that, we're running in its normal operation bands kind of thing. A lot quicker to see what the system can trend now in the E3.
Yeah, and one of the big things is that you want to trend it, you want to look at it, but you don't want to change anything. I've seen this time and time again. I've technician called me up. If that system was commissioned properly and it's been running for 6 months or it's been running for a year and somebody went back and just fine-tuned it, a year comes by and then something craps out or something drastically happened and you're getting called out, you don't need to be going in and changing parameters. It's something usually mechanical or something failed, like a pressure transducer, temperature probe, a valve may have failed, but you don't have to go in and start reprogramming the controller. Make sure if it's been running for a year, fine. Usually not going to change set points is going to fix your problem.
Yeah, absolutely. And I think especially in CO2 systems at the moment, in the last few years and the next couple of years, as a lot more people are learning and starting up their first system, is you'll see a startup on a CO2 system is typically a full week of factory reps as well, from the OEMs, from the control guys. You've got your contractor, your end. So there's a lot of people on site that are really making sure that everything works and works correctly, right? And to your point, Trevor, is like the last thing you want to be doing, and it's true in regular refrigeration systems, is that the set points are not the issue 99% of the time. But changing something just to get it to work while you're there and get out and move on to the next call. Not that anybody does that, right? But sometimes it does happen. It's just going to be a problem for somebody else later on.
Yeah. And for sure, you're going to have to do that sometimes. You're going to have to go in, you're on call, it's the weekend, you got 20 calls holding, you got to go in and change something, get them up and running. But you got to make sure you get alarms on that, you tag it, I bet you can even set some stuff up here where you're going to get an email reminder to yourself, the end user, that you got to come back and adjust something, because it's important that you do get your customer up and running, but you got to look out for yourself or the next person coming to that store, because 6 months go by, or even a couple of weeks go by, you'll forget that you even made that change. So always put in some reminders, log some stuff.
Yeah, absolutely.
Okay, this is fantastic. I know we're running out of time. Why don't we just jump in quickly on a CC200 controller and kind of give an idea, because this is something new about supermarket work now. There's case controllers everywhere, and it's something you need to start learning. And the biggest thing is just reading the manuals, investing some time playing with it. That is probably the most important thing. You got to touch it, you got to feel it, you got to look at it, but you got to get into those manuals to make sure you know what you're touching and looking at.
Yeah, absolutely. And then for those that are aware, Emerson or Copeland now, we launched a new case controller, CC200, starting to hit a lot more of our end users here in the last year. As I'm trying to load this one, this what is on a cell modem, so it might take a little bit to load up. So with the new CC200, for us is now a case controller that has multiple valve outputs. And what I mean by that is I don't have to have a different model case controller for each valve type. If I've got a stepper valve, or if I've got a pulse valve, or just a solenoid, the CC200 gives us the option to have all three of the drivers in one controller. With that also, it also comes with its own, what we call cold chain connect, which is our mobile app via Bluetooth to the controller as well. So you can connect to that case controller while you stand in front of the case, do any troubleshooting, any overriding kind of thing with that. So it's just pulled up here now. On this application, it also has the ability to do BACnet communication or Modbus communication, all out of the one controller. So which has been really good for us, because previous models of case controllers we've had in ourselves, we had different valve types, which meant a different model, different communication type, which meant a different model again, right? The product management team really did a good job here, I think, of really getting it into one part number.
Yeah, they had so many different, because Copeland or Emerson is so big, so many different control lines globally. You guys are, so it's nice that you're taking the functionality from a lot of different product lines and making like one part number is real good. I bet you OEMs are loving that compared to all the other part numbers. Yeah.
Oh yeah, for sure. Like I said, I mean, we also can expand the evaporators. So if you've got a case that has more than one evaporator, we have an evaporator expansion module where you would plug that in to the case controller. So you don't need to wire anything between it. It's like a snap block expansion module with a male end on the main controller and a female on the other side. So they just click in together. Now you've added an extra coil to that controller. So for a 12-foot case with 3 coils, you would have a case controller with 2 expansion modules, and not have to buy 3 different case controllers for the one 12-foot case.
Yeah. And that makes a big cost savings to the end users, and the complexity if you can do one case, because a lot of times there are 3 coils in that one 12-foot case, and if you can use one controller to do that.
Yeah. Oh, yeah, absolutely.
Do you have any CC200s to this E3 or no?
Yes, this one here has got a CC200. This is a single coil case.
So here we go. So you got all your temperatures and pressures. So that's one of the big things too. What have you been noticing? Because I know you've been doing a lot of field work with some of the manufacturers and the contractors. What are some of the biggest difficulties that you've been seeing in the field? Maybe it's from the OEM side, maybe it's from the contractor side. Is it the wiring? Is it the programming? Is it the setting up? What have you been seeing?
To be honest, it's probably a combination of all of the above, right? Like I say, now you've got communicating devices, so network wiring needs to be run, and that's typically done by somebody else other than a hot electrician who's doing all the hot wire, right? So you've got 2 contractors involved. One's going to bring electric to the case, one's going to bring communications to the case. Sometimes that contractor is licensed to do both, but there are nuances with network wiring. You can't star connect communicating devices, so you need to make sure that we're doing daisy chain communications and things like that. So guys that haven't dealt with that before, is a little bit of a learning curve. Most of them get it pretty quickly. Most of our literature covers that well, for at least how to connect a case controller. Then you've got all the case transducers and case sensors that come up to the case controller. 99% of them are landed correctly, but hey, the OEMs sometimes they still have humans working case lines, right? So they sometimes get a probe mixed up, and you've got to check on those things. And we try to do that before starting up a system, because the last thing you want to do while a system's trying to start up or it's already running is have to troubleshoot the placement of sensors, or they're not wired correctly and things like that.
So let's do a quick example for everyone, because I know you've been involved with a lot of the commissioning and startup over the years. So just say you got 5 cases lined up. You got a lineup, and you got 5 controllers, and they're controlling what you got, one for each case. Where would a commissioning guy start when he's going in to set these up? I'm assuming he want to go and make sure all the wires are landed properly before even touching the controller. Okay, so they land, all the wires are going in, like your temperature to your suction line, your return air, your supply air, making sure they're all in the right locations. What would be the next step for them?
Yeah, so the next step is what we need to obviously bring them online with the supervisor controller in E3. Is the files all loaded correctly? Is our communication port set correctly up in the E3. And we've got to address the device too, right? Because they got to know who to talk to as far as the E3 is concerned. If you've got the 5 cases and then it's address 1, 2, 3, 4, 5, if it's trying to communicate to 5 ones, that's not gonna work, right? So making sure our addressing is correct in the controllers and that both at the case and at the E3 to ensure they do have that peer-to-peer communication. Then from that, like I said, correct sensor placements, you've already done that, and a well-insulated suction line probe coming out of the evaporator. The way I do it is I operate 1 case at a time. And when we're starting them up, you got to try to make that time too. I mean, it's hard sometimes with some of the end users and the way that the schedules run, and somebody needs to load the case behind you. They got a cart full of stuff, but you try to do 1 case at a time. But I don't necessarily, if I find an issue in the case, I'm not necessarily resolving that issue in that case. It's very easy to then just shut that case down, make our note and say, okay, we have got an issue with XYZ. We've got a working actions list of what we need to get back to, but don't let that stop continuing our startup and getting things running. There's a lot of moving pieces, right? I've got an issue with case A, I'll move over to case B. All right, that one's good. Everything's going to be able to run there. We move on to C, and then we can come back to A and go, okay, let's fix that thing there, and then restart that action. Because now we have that communication direct to the case, it's a lot easier to narrow it down. You've got an EEV, so a stepper or a pulse valve that I can directly close that valve at the case and just deal with that case on its own.
Yeah. So you got your wiring daisy chain from your panel for your E3 out to your case controllers. Then you got to do your addressing. And to get the addressing, do you have to do it individually? So you have to go and use a handheld device. Can you use your phone? How do you say I want address 1, then address 2, address 3? How do you change those addresses on those controllers?
So you do it all through our Bluetooth app for the CC200, Cold Chain Connect. You can connect to each device and then go into the address settings tab to go in and set it to whatever address it needs to be.
Yeah, no, that's perfect. And read the manual. That's the first step 1. What we didn't say. Step 1 is to read that manual. Find time to do that. Do not throw that out the window. We're coming up on time here. I could spend probably 5 hours just picking your brain because you have so much knowledge to share. Any final thoughts, any words? I know this was quick. I really would want to do this again with you. Any final thoughts and tips for technicians out there who are either starting up an E3 or a CC200?
Yeah, probably to go to Copeland.com first for at least our product literature. That's where you're going to find everything around our products. The second thing is, if you're a contractor, just try to learn as fast as you can in CO2. There are a lot of great resources out there, a lot of great trainers as well from the OEMs and guys like yourself. We also do training over here as well. I think for the most part that the industry is fairly unison in trying to educate folks. I believe it's hard for some of your contractors, the owners of these businesses to commit to getting more training because they have service technicians and installation and that's all. That's a business they have to run too, but please beg your boss to get more training or reach out to us. We can help out.
Yeah, I love that. Brent, how can people get a hold of you, get a hold of Copeland if they want to find out more about this product?
Yeah, certainly in the website, Copeland.com. I can drop my email details in as well here for everybody to share. Mine's just Brent.Cheshire@Copeland.com. I won't share my phone number. That gets dangerous right now. I know my phone number is in many panels around the world, electrical panels. I've seen pictures. I will answer the phone most of the time. If I don't, we definitely have a great tech support team in the back ends, our group here at Copeland. They're available 24/7. So I'll share those email details with you so you can share it out at least. But yeah, don't hesitate to ask. We're here to help anyone.
Yeah, I'll put it in the show notes. Make sure that people can find that. There's people out there who want to help you, like teams like the team at Copeland, the technical support team. And once again, maybe the first person you talk to is not the right person for you to work with. Maybe you got to call 1 or 2, 3. Don't give up. And this is what I talk about every manufacturer. That person could be having a bad day. Call back and get somebody else. Talk to 3 or 4 different people because I know for sure I work and talk with all these manufacturers. A lot of people want to help you out there. I really want to thank you, Brent, for taking the time to talk about some E3s, give a few tips for the technicians. I do have a additional question here. With the addition of the stepper output on the CC200, do you think there will be an uptick in case level suction pressure modulation in conjunction with pulse valves to increase efficiencies?
Yeah, we believe there is. We've had a few discussions with some end users and some of the EORs that have been designing some of these systems, and they definitely see a benefit in modulating suction at a case level to improve efficiency in the coils and things like that. So yeah, I think we'll start to see some. We do have one end user that does it already with a couple of their coolers that they put on the medium temp coolers on the low temp suction side, just to give that low temp suction a bit more load. So we are doing suction control of those with an end user as well. So yeah, I think we definitely will.
Yeah, I love it. I think there's so many cool things happening, especially with AI and refrigeration. We're going to see some amazing things come out in the next 4 or 5 years. It's game changing. I bet you there's things that there's happening at Copeland on AI that you can't even talk about, that it's going to be amazing to see, because I've been hearing it around the world, how efficient things are getting in refrigeration. I'm super excited about it. Once again, I want to thank you for taking the time. I want to thank everybody for hanging out and listening to this. If you enjoyed this, please share this with others, because this is how this podcast grows. Once again, I want to thank you so much, Brent, and have a great day.
Yeah, thank you, Trevor, and thank everybody for attending.
Hey, thank you for watching this video. I do hope it is bringing you a lot of value. If you are looking to grow and build your refrigeration teams and want them to learn CO2 refrigeration, head to the refrigerationmentor.com website, click to contact us, and let us know how we can build a culture around training inside your organization. Let's get a conversation going.